This is HLAA, day number 1 of probability and statistics. Today we're going to be talking about central tendencies and measures of spread. So some pretty foundational and to some extent basic topics here with regards to mean, median, mode, variance, and standard deviation. However, we take it to another level here, as you'll see in a few moments. Now, the mean is a very important topic, and we're going to cover that very in depth today. We're going to refer to the mean as either mu, which is equivalent to E of x in many cases, and this E of x stands for the expected value, or we'll refer to the mean as x bar, depending on what type of data we're presented with. Okay, and then below, so we'll talk about median and mode. Those don't have a symbol assigned to them, but we'll talk about the definition, which you might already even be aware of. Okay, variance. Variance is referred to as sigma squared, which is actually related to the expected value of x. It will be the expected value of x squared. We'll talk about what that means in a little bit, as well as the expected value of x, right, or the mean squared. Okay, the derivation of that will be coming. Or we could refer to that, again, related to the x bar above as s squared, depending on the scenario. Finally, the standard deviation is simply the square root of sigma squared. So it'll just be sigma or s, depending again on the data set. So let's go ahead and get started with these, as well as some other topics within central tendencies and statistics itself. Okay, so on the slide previous, I wrote mu and sigma squared and sigma in green. Those relate to what's called a population, a data set called population. Now, when you're given a population, that means the data you're given represents the entire set. Okay, represents an entire set. Okay, and you'll notice that you're going to use some Greek letters here. We already looked at mu, right, or the expected value of x. We looked at the variance and the standard deviation, but we also need to talk about what n represents. N, of course, is the sample size, and in this case, it's not actually a sample, the population size, the total data in the set. And then this thing called the degrees of freedom, which is used when it comes to the variance and the standard deviation when we calculate it. Now, the intent or the purpose for the degrees of freedom we're not going to be discussing in this video, but you'll see that the degrees of freedom is important later on when we calculate variance and standard deviation. Okay, so population was our first type of data. Our second type of data is called a sample. So a sample is what we call a subset of the population. So I referred to this in red. This is our second type of data, or set type. Okay, this would be a subset. So we may not have the entire set, right? So this is a subset of the population. Now, the only difference between calculations with regards to variance and standard deviation is going to be this thing called the degrees of freedom. The degrees of freedom will be n minus 1. You'll see that come up here in just a moment. Of course, the size of the set is still n, right? We might refer to it as capital N at times, just to kind of keep the two types of sets separate and their notation somewhat different, but it's still just the number of items in the set. We refer to the mean as x bar, just a way to identify a sample mean instead of a population mean, and then variance and standard deviation, just use that capital S instead of sigma. So anytime that you see any notation that's Greek, that'll tell you you're dealing with a population. Let's move on to some central tendency on the next slide. Okay, central tendency. All right, these are some basic ideas: mean, median, and mode. When we look at the mean, it's the average of the data that has been collected. So within a population, right, again, I see mu, that tells me population. Right, this set would be the average of all the x's. So if you look at the summation above, and I start from I equals 1 and I go up to n, I would take the first data point, add the second, add the third, and go all the way out to the nth data point. Right? If there's n points or n pieces of data, we would take those n items, add them up, and divide by n. That would give us our population mean or average. All right, within a sample, no difference. All right, we're just using a different variable to represent it. So again, we'll have the same thing. We'll take the first, in this case, capital N items, right, or data points, add them up, and divide by the number of terms or number of points. So there really is no difference between n and capital N other than I'm just using it to signify the difference between a population mean and a sample mean. No difference in the calculation. Okay, on to the next point of central tendency, the median. This is the middle value of the data set. So if you have an even number of data points, I'm going to represent them with these dots. Here's 6 data points. The median, referred to typically as Q2, will land between the middle two. So we would average these two values to get the median. If we had an odd number, let's say we dropped this last one, then we would have 5, and therefore the middle value would be our median. So when you're dealing with a set, depending on how many points there are in the data set, will determine how you will calculate your median. The mode, pretty straightforward, is the data point that appears most frequently in the set. If multiple data points occur in the same frequency, then the data set could be bimodal. We'll see that in a little bit here. The quartiles are the numerical values that divide the sample into quarters. Now we already talked about one of the quartiles, which is Q2. There are 2 other quartiles, which would be Q1 and Q3. Okay, so these 3 quartiles split the data into fourths. The interquartile range is the middle 50%, right, between Q1 and Q3, and that range is calculated by taking Q3 minus Q1. Outstanding. Let's look at a quick example here. We're going to find the mean, median, and mode of the quartiles in the IQR. Excuse me, mean, median, mode, quartiles in IQR. Now, let's make an assumption. This says sample, so let's say then that if we find the mean, we're finding x bar. No difference in calculation than finding mu, but let's make the assumption that all we've got here is a sample of the population. Okay, so the average, what would that be? Let's add those values up. So 2 plus 5 plus 7 plus 9 plus 23 plus 23. Okay, that comes out to be 69. And we've got 6 values, so we'll divide by 6. So x bar could be written as 69 over 6, or we could write it as 11 and a half. Okay, let's look at our median. Okay, our median, again, there's no symbol for median. So we're going to take the set, we're going to determine how many terms there are. I've got 1, 2, 3, 4, 5, 6. So I'm going to take the third and the fourth terms, and I'm going to average them. So the median, right, will be 7 plus 9 divided by 2, which will be 8. All right, the mode, clearly, we can see based on looking at our terms, will be the term that happens most frequently, which will be 23. Now let's take a look at adding an additional term and see what that does to our set. So let's add another 2 onto the front. Okay, so that changes a lot actually. And in this case, let's say that this is now the population. Okay, so when I add that 2 in there, I now have the population. That means I'll be finding mu, for the mean of this population. That's just going to add 2 additional units to the numerator of x bar, and 1, because we're adding 1 term to the denominator. So we'll have 71 over 7. I'm going to leave it like that. I don't feel like having a repeating decimal happening here, so I'm going to leave it like that. Let's recalculate our median. Now we have an odd number of data points, and therefore Q2, our median, would be 7. And then our mode in this case is going to be 2 different values, 2 and 23. So this is what we would call bimodal. Now let's go back to the original set. Right, our sample 2, 5, 7, 9, 23, and 23. And let's find Q1 and Q3 so we can find the IQR. Okay, so let's put a spot here for Q2. Q2 is 8. Here's Q2. Now what we do to find Q1 is we split the lower half in half. Okay, so when you have an even number of numbers, the middle of your lower half is going to be Q1. And the middle of your upper half will be Q3. So you can tell this is heavy to the right side, right? So this will likely be, most of the numbers are packed within that first 9 digits, and then it's strung out over to the right. So we would call this more of like a skew right or skew positive, but we could see that Q1 would be 5. So let's put these over here. Q1 equals 5. We already knew Q2, that's 8, and Q3 is 23. So our IQR would equal 23 minus 5, which will be 18. Okay, let's do the same thing for our second set. When we had an odd number of numbers, something similar results. So we're going to take our lower half, which will be 2, 2, 5, and our upper half, which will be 9, 23, 23. And of course, we find the middle number. Since those are both odd sets, Q1 would be 2 and Q3 would be 23. So we have a slight change. Q1 will equal 2. Q2 we already knew was 7. And Q3 will equal 23. So our IQR expands a little bit, giving us 21 for that IQR. Okay, that's how you work through finding mean, median, mode, quartiles, interquartile range. Let's continue with some more examples. All right, so I want to highlight here on this slide. First, we're just going to talk formulas on this slide for variance and standard deviation. Okay, so let's talk variance first. Standard deviation follows really pretty slick from there. Okay, so the variance is different than the mean. Okay, let's see how. All right, the mean is add up all the numbers, right, or all the data points, divide by the number of data points. All right, so that would be like x sub I summed from 1 to n over the number of terms n, or the number of data points. But here we're going to take each of the terms individually, subtract the mean. So this is like the variance from the mean, or the distance from the mean squared. We're going to sum up all the differences from the mean, square them, or distances from the mean, you could refer to it as well, and then divide by the number of terms. So in essence, what you're doing is you're finding the absolute value of the distance from the average, squaring it, and then dividing by the number of terms. So we're averaging the distance squared. Okay, so let's lay that out. Maybe that didn't make sense verbally. So we would take the first term, subtract the mean, square it. Second term, subtract the mean, square it. Third term, subtract the mean, subtract the mean, square it all the way out to the nth term, subtract the mean, square it, and divide by the number of terms. Okay, the only difference between the variance for, in this case, a population and for a sample is the Greek lettering, which we already knew, plus, check it out here, this is important to note, when you're dealing with a sample, this is where the degrees of freedom comes in. Okay, so we're going to divide by n minus 1, not n. So you'll do the same thing as we did for population variance, except now we're going to take each of the individual terms minus x bar. That's just the mean of a sample instead of the population. For brevity, I'm going to shorten this up. Take the nth term minus x bar, square it, and divide by 1 less than the number of data points. Okay, standard deviation, the exact same calculation, except we take the square root of our result from our variance. Okay, so let's put this into play. All right, this example says find the mean, the variance, and the standard deviation of set B as a population and then as a sample. Okay, so let's work the population. Let's first find the mean. Okay, so for the mean, we're going to add our terms up. 1 plus 1 plus 1 plus 2 plus 5 is 10. Number of terms, 5. Our mean is 2. Okay, so sigma squared, our variance, is going to be each of the individual terms, 1 minus 2 squared. Okay, 1 minus 2 squared. Now, instead of writing out 3 of those, I'm actually just going to multiply that by 3. I would have 3, 1 minus 2 squareds. Then I would have 1, 2 minus 2 squared. Then I would have 1, 5 minus 2 squared. Now each of these 2's, here and here and here, they represent the mean of that population. All right, I can't forget to then take the sum of the squares and divide it by the number of data points. So sigma squared is going to be 3 times 1. Right, 1 minus 2 is negative 1, squared is positive 1. So that'll be 3. Our second term will be 0 squared. Our third term will be 3 squared, which will be 9. We're going to divide that by 5. So it looks like sigma squared comes out to be 12/5. That's the variance of this population. The standard deviation will be the square root of that. All right, so I'm going to do a little varsity math here and write this as 2 root 3 over root 5. Okay, that would be our standard deviation if this were the population. Now let's work with the sample. So if this is a sample, there's going to be no difference between the sample mean and the population mean. No calculation difference. It's when we get to the variance where the calculation changes. Now, nothing will be different about the numerator, so I'll still get 12 in the numerator. However, the denominator, remember, is n minus 1 degrees of freedom. Okay, so sigma squared, or excuse me, s squared is going to be 3. So that's clearly going to change our standard deviation, which will be the square root of 3. Your standard deviation will always be positive, so you won't have to worry about a plus or minus when it comes to working with a square root by taking the square root of the variance. Okay, that's a little practice there with finding mean, variance, standard deviation, both population and sample. Let's continue with a couple more examples. Okay, a couple of very typical paper 1 style questions where you're prompted to find an unknown given some data, right? So in the following example, it says find m given the mean of the set A is 6. Okay, so I've got this set A. Looks like it's got 1, 2, 3, 4, 5, 6, 7, 8 terms. So this set, I'm going to make the assumption is a population if I'm not told otherwise. Okay, even though it won't matter for the mean calculation. So mu will equal the sum of those 8 terms divided by 8. So if I add the 8 terms, it's 2, 7, 10, 17, and 21. Okay, so 21 plus 3 m's over 8 is equal to mu. Well, I'm told that mu is equal to 6. If I can just do a little algebra, that tells me that 48 is equal to 21 plus 3m, which tells me that 27 is equal to 3m, which means that m has to equal 9. If I were to allocate points for this, or marks, I would say this would probably be like a 2-mark question. Pretty simple. They'd probably, if this were an exam question, it'd probably be a little beefier and require a little bit more from you. Okay, example 2. Prove that the variance of any set of 5 consecutive integers is 2. Okay, so I'm going to start this by saying let x be an integer. That allows me to write the following, that x and then x plus 1 and then x plus 2 and then x plus 3 and then x plus 4 represent 5 consecutive integers. Okay, now it wants me to prove that the variance of this set, and this, by generalizing this to some arbitrary x value that's within the integers, is valid for showing that this is true for any set of 5 consecutive integers. By definition, these are 5 consecutive integers if x is an integer. Okay, so what that tells me is that mu, our average or our mean, which is required in order to find the variance, would be 1, 2, 3, 4, 5 x's plus 1, 3, 6, 10 divided by 5 terms, or 5 data points. Now, if I were to reduce that out, I can see a 5 would reduce out both 5x and 10, leaving this as mu is equal to x plus 2. Okay, pretty simple definition for mu. Now to find sigma squared, I'm going to take each of the individual terms and subtract x plus 2. So my first term, x minus x plus 2 is going to be a negative 2. X plus 1 minus x plus 2 will be a negative 1 squared. X plus 2 minus x plus 2 will be a 0 squared. You can see where this is going. These terms are all going to be, well, you can see 2 units from the mean, 1 unit from the mean, 0 units from the mean, 1 unit from the mean, and again 2 units from the mean. And I'm going to divide, of course, if this is a population, which I'm going to make the assumption, right, since it doesn't tell me otherwise, I'm going to divide by the number of data points. So sigma squared is going to equal, that'll be 4 plus 1 plus 1 plus 4, which is 10, divided by 5, and thus the variance of any set of 5 consecutive integers is 2. All right, let's continue. Okay, interesting exam style question here. Let's read it and then we'll set it up. 4 numbers are such that their mean is 13, their median is 14, and their mode is 15. Find those 4 numbers. All right, so again, I don't know much about those numbers yet, so I'm going to let x1 be less than or equal to x2, be less than or equal to x3, be less than or equal to x4. Okay, where each of these, right, x sub i's are in the real numbers. Okay, so that tells me what I've got here, right? If I've got that their mean is 13, right, then that tells me that mu equals 13, thus 13 is equal to x1 plus x2 plus x3 plus x4, all divided by 4. Okay, so let's go a little further with that. It tells me that 4 times 13, which is 52, is equal to the sum of those 4 numbers. Okay, probably want to hang on to that. All right, their median is 14. Their median is 14. Let's highlight that in blue. So if I have 4 numbers in a data set, then the average of the middle 2 numbers, right, which would be x2 and x3, the average of those 2 numbers would be my median. Okay, that's good information, which means that x2 plus x3 would be 2 times 14, which is 28. Okay. Now we got to do a little bit of work here. So let's write something out here, and let's talk about the mode. All right, this is where some of your creative thinking might be better than mine. I don't know. Okay, their mode is 15. Okay, so since their mode is 15, then x2 is less than 15. All right. Now, how do I know that that's true? Well, let's consider if x2 was 15, right? Let's say x2 was 15. Then x3 would have to be greater than or equal to 15, which would not allow for x2 plus x3 to be 28. So that tells me then, just by a little bit of logic, that x3 and x4 are 15. Right? x3 and x4 are 15. Now I know that if x2 and x3 is equal to 28 and x3 equals 15, then x2 must equal 13. Okay, so let me kind of highlight some items that I know now, or I think I know. We'll confirm them in a little bit. I think that x3 and x4 are 15, and I think x2 is 13. Okay, therefore, if I were to, kind of put this all together and say that I knew that 52 equaled the sum of the first of those 4 data points, then by addition, simple addition, then that would mean that x1 would equal 9. Okay, so x1 would have to equal 9. And so 9 plus 13, of course, is 22, and 22 plus 15 is 52. Okay, and there you have it. So if we were to put them all together, we could confirm that all of this is true. All of our information, at least. So we have 9 for x1, 13 for x2, 15 for x3, and 15 for x4. Let's check to see that we meet all the criteria here. Our mean is 13. Well, let's add them up. All right, mu 52 divided by 4. Yep, that's 13. That checks. Our median is 14. Well, as I look at the data points, or the data, I've got 4 points. The average of 13 and 15 is our median, which would be 14. And the mode, of course, is 15. We can see that clearly in the set, so that checks as well. And there you have it. That's a nice exam-style question. We're going to move on to the next slide, where there's another exam-style question that's got some beef to it. So let's get to it. Okay, so we're going to get started here on this question. And one item that I haven't covered yet, which I will in a separate video, is that I think I did discuss it earlier in the notes, but I haven't derived this yet, is that the variance is equal to the expected value of x squared minus the quantity of the expected value of x squared. So the expected value, and I go into this in the video for that, of x squared is going to be the sum from I equals 1 to n of x sub I squared divided by the number of terms, whereas the expected value of x quantity squared is literally mu squared, which is the sum from I equals 1 up to n of x sub I over n quantity squared. So that's the difference between those two. This equivalence statement is useful, and actually it seems complicated, but it is very useful later on. So I'm going to go ahead and utilize this in the example that follows. So let's get to it. The 10 numbers, x1, x2, all the way up to x10, have a mean of 10 and a standard deviation of 3. So if the standard deviation is 3, then the variance is 9. Okay, let's hang on to that. Okay, if the mean is 10, then the sum of the terms up to from 1 to 10 of x sub I will equal 100. Whoops, 100 has 2 zeros. There it is. Okay, how did I know that? Well, the mean, if I divide the sum of the terms by 10, I get 10. If I don't divide it by 10, I have 100. Okay, we're going to use that in just a moment here. So the first thing I'm actually going to do in order to work through this question is I'm actually going to expand this. All right, so let's expand x of I minus 12 squared. Well, that would be x of I squared minus 24x of I plus 144. Okay, so let's expand this. And then I'm actually going to distribute the summation to each of the terms. So this would be equivalent to the summation from I equals 1 to 10 of x of I squared minus, I'm going to pull this constant 24 out in front of the summation, I equals 1 to 10 of x of I plus the summation from I equals 1 to 10 of 144. Okay, let's treat this as 3 separate terms. Working with them, let me highlight them to keep them organized. Let's go blue for this. That's cool. Let's go green for this. That's cool. And we'll go purple for the last one. How about that? Yeah, oh, nice, I like that. Okay, so let's talk purple first. It's gonna be kind of nice. If I added 144 10 times, all right, 10 of them, right, from 1 to 10, we get 1440. All right, let's case that up, house it for later. All right, hold on to that one. Okay, now let's go green. Let's go green. Green would be very closely related to the mean, right? And I actually already have it. This would be the first term plus the second term all the way out to the 10th term. The sum of the first 10 terms. So the mean is the sum of the first 10 terms divided by 10. So what did I do? I did a little legwork here at the beginning, which comes out to be useful. Now note that the green term is 100, but we're going to multiply by 24. So we'll end up getting 2,400 in a moment. All right, blue. Let's work some blue. Oh boy, blue. All right, from 1 to 10 of x of I squared would equal x of 1 squared plus x of 2 squared all the way up to x of 10 squared. That's the sum of the squares. Okay, now sigma squared, let's do a little work with this. Sigma squared, as we know, at least now, as we know, right, is equal to, oh my goodness, highlighter mode, let's go. The sum of the x squareds minus the mean squared, or the expected value squared. So that's going to be our variance. All right, so let's take this equation. Well, we know sigma squared. And we know that this here is 9. We don't know the expected value of our x squareds. And we don't know that, but we do know the expected value of x. That's going to be mu, or mean. So when it comes to solving for this blue term, that blue term is closely related to the expected value of the x squareds. So the expected value of the x squareds is equal to the summation from I equals 1 to 10 of each of these squared values divided by n, or in this case, divided by 10. Okay, so what we're going to do is we're going to work this out, right? We're going to solve this equation up top, right, which looks like the expected value of the x squareds is going to be equal to 9 plus 100, which is 109. Okay, cool. So if I know that this is 109, then I know that the sum of the squared terms is going to be equal to 1090. All right, so our blue term is 1090. All right, there we go. So let's figure this out, evaluate it. I got 1090 minus 24 times, what's my green term? That's 100. There it is. And plus 1440. All right, do a quick calculation on that. And our answer is that this summation evaluates to 130. There you have it, guys. Using the definition of sigma squared in terms of the expected value can be helpful, and understanding the connection is vital. So again, I'll post a video on the derivation of that equation, and I'll see you in the next video. Have a great day.